Today I'm going to introduce the Pascal law, a basic concept in fluid mechanics for mechanical engineer. I will quickly review the concept of fluids and fluid pressure. Then I will focus on the concept of Pascal law. At the end, I will have a quick summary on today's contents. Since you are the second-year mechanical engineering students, I assume that you all are familiar with the concept of fluid and fluid pressure. Therefore, I will just give you a quick review on them. First, what is fluid? Broadly, we might group all material into two categories, either solids or fluids. We all understand that the difference between solids and fluids is that solids have a definite shape, whereas fluids do not. There are two types of fluids, being liquid or gas. The difference between them is that liquids have a definite volume, while gas do not. Now, pressure is equal to the force per unit area. Alternatively, force is equal to the product of pressure times area, and the area is equal to the force divided by pressure. Therefore, for the same amount of force, the smaller the area, the higher the pressure exists. Similarly, for a given area, the larger the force applied to, the higher the pressure exists. This explains why a woman's high heel sink into soft ground, but the larger shoes of a much bigger man do not. It is also noted that for atmospheric pressure, as you go higher in the mountain, atmospheric pressure decreases because the amount of air above you also decreases. However, for underwater pressure, the water pressure increases as you travel downward, and the water pressure is greatest at the ocean floor. Now, Pascal law was discovered in 17th century by the French scientist. It is stated that pressure at any point in a body of fluids is the same in every direction, exerting equal force on equal area. That is, the force applied to the piston extends uniformly throughout the fluid, causing it to push outward with equal force per unit area on the walls and bottom of the cylinder. This works for both gas and liquids, as they both are fluids. As shown in this slide, if we draw a bottle of water with arrows to illustrate the inside pressure, it can be seen that when the water bottle is squeezed, the pressure is increased, and this change in pressure is transmitted equally to all parts of the fluid. This change in pressure is not disappear even over large volume. This explains when you squeeze tube of toothpaste. At the one end, the pressure of toothpaste does not just go up at that place where you are squeezing it. The pressure is transmitted throughout the toothpaste. This pressure goes up by the same amount everywhere in the tube. Pascal law gives us the mechanics to do a great deal of work with hydraulics. For example, when force is applied to one side of the piston, the force is transmitted through the fluid to other side of the piston. If the area of the pistons are the same, the force at the piston are the same. However, if the area of the piston are not the same, the larger the area of the piston, the greater the force at the piston. That is, through an adjusted area of piston, we can lift a large amount of weight, like a car, with a small amount of effort. The multiplication of force is determined by the area ratio between the target piston, as shown in this slide. Pressure on fluid in small cylinder usually supplied by an air compressor or compressor air. This slide gives you more examples of application of Pascal law in mechanical engineering. Because the fluids filled in the highlight area are confined static fluid, according to the Pascal law, the pressure is the same in every direction, and any change in the pressure of the fluid transmitted uniformly in all directions throughout the fluid. Therefore, Pascal law in fact reveals the underlying principle of how fluid transmit power. In summary, after quickly reviewing the concept of fluid and the fluid pressure, we focus on the concept of Pascal law. We discuss what is the Pascal law and the application of Pascal law. It reveals the underlying principle of how fluid transmit power and hydronic multiplication of force.